Hey Greyfriars, welcome to week 24 science. We are starting with the laws of thermodynamics. Have some grace with Mrs. Massengill and I, because this is the first time we are going through all three laws of thermodynamics at Greyfriars. So stand back, here we go. We are starting out with stuff that will totally be, I think it should be easy for you to grasp. The first law of thermodynamics is also known as the law of the conservation of energy. What's a law? Okay, kind of like a rule, right? A rule that is always true would be assumed a law, okay? What does conservation mean? If you conserve something, whether trying to conserve resources or the environment, or conserve energy, like bears hibernate during the winter to conserve energy, right? It means to try to avoid wasting. So keeping the same amount of something. And what is energy? That was part of our memory work. Do you remember it? Oh man, I'm gonna have to flip to my notes just to make sure. Energy is the ability to do work. I wanna make sure I had it right. The other thing is, do you guys remember what are two types of energy? Potential, kinetic. Remember I held the pencil up and dropped it. Potential energy, gravity's pulling down on it, it wants to move, and it moves, right? Potential energy is the energy stored in it. Gravitational potential is not the only type of potential energy. That's the main thing to remember from today. Kinetic refers to any kind of movement or motion. So today, I want to talk to you about the law of of conservation of energy, which is our first law of thermodynamics. Your memory work for today is energy cannot be created or destroyed. Remember, I told you this several times. I love to think of it in terms of when God created. At the very beginning, reading Genesis, God spoke into existence all the energy there will ever be, right? Energy cannot be created or destroyed. There's nothing that we can do to add energy to our system or take away energy. But remember my little Newton's cradle where I had those 5 balls in a row and they swing? I would pull back one and it would swing and they would keep going back and forth, hitting each other. That's a transfer of energy. The first ball hits the second ball. Its energy is transferred. The second ball can't go anywhere. All of its energy goes to the third one, to the fourth one. The fifth one can go somewhere, so it swings up. So kinetic energy of the first ball coming down becomes potential energy of the last ball. Once it reaches the top, it becomes, the potential energy pull is maximized. It has no more kinetic energy, and then gravity pulls it down, and it's kinetic energy, and it keeps going back and forth like that. But what did we notice? We noticed that the longer it went, eventually the balls didn't go as high. Why? Why? If energy can't be created or destroyed, it's always there. Why did they stop? Because in ours, all energy is, you can lose energy, essentially. So every time those balls hit each other, what did we notice? We heard the sound, right? Sound is a form of energy. Did you know that? Energy can take several forms. There's nuclear energy, energy from atoms, right? There's radiant energy from the sun or any light source, right? There's chemical energy from chemical reactions. There is kinetic energy, which is the energy of movement. There's electrical energy. There is, trying to think, what are my other ones? We'll get to them as we're going along. But every time that the balls hit, we would lose some of that energy, the kinetic energy, to sound. We would also lose a little bit to heat caused by friction. Remember what was friction? Like when we pushed the box across the ground, if we were on ice, there's very little friction, so it's easy. If we're on a thick rug, it's harder because some of our energy is being lost to friction. You'll learn more about that as you get older, but just remember that friction is kind of working against you. One thing, if I say, let's represent my energy with pencils. And if I have 5 pencils, even if I hide one, So now you only see 4. Do I still have 5? Yeah, I still have 5. It didn't go away. I still have it. Mrs. Massingill had a funny example. That's kind of like Legos. If you have 2,000 Legos in your house, you always have 2,000 Legos in your house, even if one is hiding under the couch, right? So, energy is transferred sometimes, and sometimes it appears to be lost, but really it's just changing form. Whatever is lost from one thing appears in an equal amount in another form. Make sense? I love to think of roller coasters. How many of you love roller coasters? Carowinds opens in like a month and a half. So exciting. It is true. May 18th, I think. So when you go on the Fury, I hope you don't go on the Fury. That's crazy. The roller coaster goes up above the clouds on some days. And when you're at the very top of the roller coaster, you have lots and lots of what? Potential energy, stored energy, that moments that you know something's going to happen. Then all that energy gets converted into kinetic energy as you're going down. When you reach the bottom, there's no more potential energy. All of it has been transferred into kinetic energy. Wait, has it all gone into kinetic energy? No. Some of it has been lost to sound or heat from friction. Even as perfectly designed as roller coasters can be, they still have some rubbing together that causes friction, which is heat energy. Okay, so the roller coaster reaches the bottom, then what does it do next? It goes up. But have you ever noticed on roller coasters, unless they have another point where they get pulled up again and more work is added, each hill is smaller than the one before it. That's because some of your energy is lost. It doesn't disappear. It is just changed to sound or heat energy. Make sense? So, one thing you can also remember, do you remember at the beginning of the semester when we were first talking about physics? Oh, it was scary. But we tied the water bottle to the ceiling and I pulled it back to my nose and I closed my eyes and I let it go and it swung across the room. Did it come back and whack me in the face? No. Even though it was very hard to trust this law, it is true. The water bottle will never punch me in the face unless someone pushes it, right? So, some other examples. Let's just talk through some of the examples of how, let me see. Energy changes form. I'm going to show you some examples. So, I plug in my hair dryer, right? That's electricity, electrical energy. The electricity does what? It turns a motor, right? That's mechanical energy. The motor causes the fan to blow, which creates, and it also heats coils. So it's released as sound energy and thermal energy. Make sense? The same amount of energy all the way through, but it just changes form. How about the fuel in your car? Do you use up your fuel? You use, the gas may burn up, but the energy, fuel energy, is a chemical energy. That just changes form. The same amount of energy is always there, but the fuel energy is a chemical energy, becomes mechanical energy, which becomes kinetic energy, right? So mechanical just means a machine, a motor. So you have chemical energy from your fuel burning, which technically then thermal energy, which then heat causes the expansion of gas. We've learned about all this stuff. Do you see how all your pieces from this year are coming together? As the gas expands, it pushes the pistons that then causes your engine to spin, which creates mechanical energy. And then as your engine spins, a whole bunch more to the process, eventually your car moves forward. Make sense? So cool. All of these pieces that you've learned, and you guys are not even in middle school yet. Think of how much you'll know in high school and college. My goodness. Okay, how about a battery? Do you know how batteries work? Oh, I would love it if you guys asked your parents to research with you. I didn't know how a battery actually worked. I know the basic idea of it. But when you really think of the chemical reaction going on in a battery, you have two different types of chemicals. One of them wants to receive electrons, one wants to give electrons. Do you remember learning this stuff last semester in chemistry? So the way that they interact, the chemical reaction that happens produces electrical energy. What can you use batteries for? Lots of things. Didn't you know you can use it to create, so the chemical reaction in chemical energy of a battery can create electrical energy, which then can be used to create thermal energy. Like your mom may have a portable hot iron for her hair, or a battery-powered thing to boil water on camping trips, or lots of battery-powered things, like things to steam your clothes can be battery-powered. You can also put batteries in what else do we use camping? Flashlights, right? You can use a battery, chemical becomes electrical, becomes light energy. Or you can also use a battery to create sound, whether hearing aids, use it to amplify sound, or you can use it for a radio. What else do we, or to make those annoying sirens that come with your little kits, science kits. Not annoying. I love them. You can go and buy more, you guys. I want to show you something else. Hold on, Holly. Can you grab the yellow thing on the counter for me? Hold on. So, hold on. Grab the yellow thing on the counter. Go look for the yellow box on the counter. What kind of energy is it when you rub your hands together? It's kinetic. Something is moving, right? What kind of energy is being produced? Feel how warm your hands get. Heat energy, right? I want to show you something else we just got for emergencies or for camping. This is a radio. Holly, will you sit down right there and watch? Can you sit? Nope, you can't. This one has a solar panel. So it uses radiant energy from the sun to charge a battery, which creates chemical energy, which becomes electrical energy, which can be used to make, let me see if I can turn this on.
Tonight, mostly cloudy with a 20% chance of showers.
Yeah, sound energy, right? So a lot more involved in there, right? Another thing is this also has this special tool. So I can actually turn this to charge the battery. So kinetic energy becomes chemical energy, becomes electrical energy. And then I can charge my phone from it. I can turn on a flashlight with it. Or I can play the radio.
Cloudy.
Right? So cool. You guys, I hope you enjoy learning about this. Let's think of some other things. What about when a plant does photosynthesis? Do you know what photosynthesis is? When it's out in the sun and creates sugars. So that's a chemical process. Didn't you know that? Making the sugars. We learned all about sugar when we learned about bonds during chemistry. So photosynthesis, sun energy, which is radiant energy, becomes chemical energy, right? And what about when we eat an apple or eat a leaf of lettuce? There's more involved in that process, then break down the food. That's a chemical energy. And then we go run and play. Kinetic energy. Lots and lots of conversions all the time around us. And it all started when God spoke it all into existence. He made the energy around us. He made the atoms. He made the sun. He made you. And I hope that as you're learning about this, you realize how the more you study this, you are glorifying God. How about, have you thought of how we get electricity to our houses? We're going to be studying electricity later this unit. But some main sources in Charlotte, we mostly have nuclear energy. There's a nuclear power plant where they take radioactive materials and split atoms, basically. And they take the energy from the atom to heat water. And that steam moves turbines that produce electricity. So you have nuclear energy, becomes heat energy, becomes kinetic energy, becomes electrical energy. I guess technically mechanical energy, then electrical energy, and then it brings power to your house where you can use it for light or heating stuff or for playing music or lots of things, right? Other forms of electricity, ways of producing electricity are water. We visited the Hoover Dam on our way to the Grand Canyon. There are lots of places that have dams where water spins turbines. So water has the potential energy from water, creates the kinetic energy of the turbines, which then, as the turbines move, that can generate mechanical energy, which becomes electrical energy. Wind can also spin things. You can also burn coal. So chemical energy of coal. Do you remember what coal is? It's a form of carbon. Remember from last year in geology, guys? So you burn coal. So heat energy heats water, which becomes steam, which spins. So heat energy. So chemical energy becomes heat energy, becomes what would be our next step, you guys? When kinetic energy of the thing spinning becomes mechanical energy, becomes electrical energy, becomes everything around your house. So cool, you guys. So quick review. You guys are doing great. Sorry that I don't mean to just chat, but I hope you're thinking as you look around you. Go find some things around your house and say, how is this powered? How is energy forming? Have you ever thought when you go and wrestle with your sibling, that's a change of energy, right? So you run at your sibling and then tackle them. Don't do that, guys. Love your siblings. But if you do, there's a transfer of energy. Your kinetic energy gets transferred to your sibling as you tackle them, right? Or if you kick a football or a soccer ball or hit a baseball. It's baseball season, you guys, right? As you're hitting the baseball, your kinetic energy gets transferred to that ball, right? The same amount of energy is always in the system, sometimes is lost to some sound or heat. If you've ever played pool or bocce ball, that's more noticeable that you lose some of the energy to sound. If cars crash, the kinetic energy of one gets transferred to the other, right? But some of it is lost to heat or sound. Make sense? So it's all around you, you guys. Try to find some things that are the other way around, like something that's hot that causes something to move. Any other ideas, Holly? You guys have lots of good ideas. Oh, maybe if you... Oh, I love the example of when you have a fire, a candle, and you put like a windmill type... you cut a circle out of a piece of paper so it spirals upwards, and you hang it above the candle. Make sure you do this with a parent so that the paper does not catch on fire. You can also do it over a light bulb. But the fire is a chemical energy of the flame, becomes heat energy, and then as it heats the air, you can tell that the air is moving because the spirals will start moving above it. That's kinetic. All around us. So tremendously cool. Next week, we're going to get into the second law of thermodynamics. And then we'll finish up with the third, which is really hard, but I know you guys can handle it, right? Don't you think so, Holly?
Well, only the fifth graders.
No way! You haven't met my third graders. They're pretty brilliant. Okay, so let's see if you guys can remember some of the stuff we've learned today. Okay, I'm going to ask you, sorry to be flipping through my pages. I should have had it out. Okay, so the second part of the law of conservation of energy is that energy can change forms, but it cannot be what? Energy cannot be...
created or destroyed.
Yes, nicely done. Moving objects, thermal energy, electricity, and sound energy have what? Is it potential or kinetic? Kinetic, right? Moving objects can be kinetic energy. Sound, so that's an interesting thing. We'll get into it, you guys. when things can move. Remember, atoms are always moving too, and we're going to get into waves. Lots to study still. You guys have the rest of your careers. Chemical compounds, an object lifted up, a rubber band, and your muscles have what? Potential energy, stored energy, right? How about when the nuclei of an atom of one element are changed into nuclei of atoms of a different element? What kind of energy is released? Nuclear, right? Nuclear energy. Okay, let's think of this. A rubber band in a toy airplane unwinds. So when a rubber band is twisted up, that's called elastic potential energy. Remember, kind of like the springs? Elastic potential energy. Changes to mechanical what energy? When you wind up the airplane and then you release it, it unwinds and it becomes, it's moving, so it's kinetic energy. Let's try one more. You throw a ball. What kind of potential energy is that? You're throwing, so it's your kinetic potential energy becomes mechanical kinetic energy, right? Kind of confusing, you guys? No, sorry. Why did I say that? I was so confused for a moment. Chemical energy. So you have the apple in you, that's chemical energy, becomes your kinetic energy that you're throwing the ball. Make sense? I totally said kinetic twice, didn't I? It's too late at night and I'm recording this video. You guys, long video. Thank you for sitting through it with me. I hope you guys go have fun exploring your house. Go find heat. Go find electrical. Go find spring or elastic. Maybe some thermal, sound. So we said heat already. Sound, light, batteries, chemical, fuels. Think through all these things around your house and maybe try explaining it to your parents or your siblings. Have fun, you guys. Bye.